Today we are going to learn about ionic bonding with transition metals. Our question of the day is, what do you know about transition metals? So, what is a transition metal? Transition metals are metals in groups 3 through 12 on the periodic table. So, they're in the D block. Now, each transition metal can have multiple oxidation states or charges depending on what it is bonded to. This means that transition metals can choose how many electrons they're going to give away when they bond with other atoms. This happens because they have the ability to adjust the inner core electrons by moving electrons between d and sp orbitals. That's part of the reason why we get the d shift in electron configurations, because transition metals move their electrons to be more energetically favorable for them. So, for instance, if you look on your periodic table and find copper, it's number 29 and its atomic symbol is Cu. Copper can be either a positive one charge or a negative one charge. This means that whenever copper bonds, you need to determine if it gives away one of its electrons or two. Now, let's make use of the crisscross rule from yesterday by undoing the crisscross. In this case, CuCl, there's no subscript, so they're both ones. When we uncrisscross, you get Cu with a +1 and Cl with a -1. How did we decide that Cu was +1? Well, it's a metal. So, in this case, copper is going to have a +1 charge. It's going to be named copper 1 chloride. Notice how the 1 is a Roman numeral. We'll learn more about this later. Copper chloride is a white solid with a melting point of 426 degrees Celsius. On the other hand, we have CuCl2. When we uncrisscross this, we get a charge of +2 on the copper. We call this copper 2 chloride. In this case, we form a blue solid. So the melting point of copper 2 chloride is actually higher, 498 degrees Celsius. So how do we determine the charge of a transition metal? Well, the first option is to just read it if it's given. Here, the copper has a +2 charge. Another option is if you're given the name of the compound. In this case, you find the Roman numeral in parentheses. That will be the metal's charge. Here, the charge is +2. The next method is the one I showed you a minute ago. You uncrisscross. However, whenever you do this, you have to make sure the charge is real. Watch out for formulas that were reduced. For example, CuO. If you see CuO, you uncrisscross, you get Cu +1 and O -1. However, we know that oxygen is always -2. That means the formula was reduced, and the copper charge is actually +2 in that case. So, why do we care about what the charge is of the transition metal? Well, as it turns out, a difference in charge is a really big deal and can give the substance very different properties. For example, chromium +3 is required to live a healthy normal life. However, chromium +6 is very toxic to our bodies. Now, pause the video and try the show what you know questions. Here is a list of Roman numerals in order. So 1 is I, 2 is II, 3 III, 4 IV, so 1 before 5. 5 is V, 6 is VI, so 1 after 5. 7 is VII, 8 is VIII, 9 is IX, or 1 before 10, and 10 is X. These are all the Roman numerals you might need for charges. Now let's crisscross our charges to bond the transition metals together. First, we have Cu plus 2 and Cl. Since Cl has a -1 charge, we crisscross and get CuCl2. Now, let's look at nickel plus 3, phosphorus -3, and when we crisscross, we get Ni3P3, which can then be reduced to NiP. Third is Ti plus 2 and O, so titanium and oxygen. Since we know oxygen has a -2 charge, we get Ti2O2, which simplifies to TiO. Now, number 4 is iron 3 oxygen. Iron is plus 3, oxygen is -2, so when we crisscross, we get Fe2O3. For number 5, we have manganese 4 and sulfur. Sulfur has a -2 charge, so when we crisscross, we get Mn2S4, which simplifies down to Mns2. For number 6, we have vanadium, V, with a +3 charge, and selenium, Se. Since we know that selenium has a -2 charge, we can then crisscross these and get V2Se3. Now, for our final example, let's look at vanadium, 5, and silicon. Well, silicon has a -4 charge, so when we crisscross, we get V4Si5. Now, let's look at part 3. We're going to uncrisscross to get the elements by themselves and find the charges of the transition metals. For number 1, since oxygen does indeed have a -2 charge, we know we are good. Now let's look at number 2, COS. When we uncrisscross, we get CO plus 1, S minus 1. However, sulfur actually has a -2 charge, so we need to double all of our charges, and CO is now plus 2. For number 3, let's look at CRN. When we uncrisscross, we get Cr plus 1 and N minus 1. However, we know that N is actually -3. So we need to triple our numbers and get Cr plus 3. Now let's look at number 4, Mn2O7. In this case, when we uncrisscross, we get Mn plus 7, O minus 2. Since O does indeed have a -2 charge, we are ready to move on. Now let's look at number 5, MnO2. In this case, when we uncrisscross, we get Mn plus 2 and O minus 1, because of course, no subscript means 1. However, when we do this, we find that this would mean that oxygen has a -1 charge, which is not true. Oxygen is -2. So we need to double all of our charges, and we get manganese is plus 4. Now let's look at number 6. We have V3P5. When we uncrisscross, we get V plus 5, P minus 3, and since phosphorus does indeed have a -3 charge, we are good on number 6. For number 7, we're going to use AuCl. No subscripts means they're both 1, so when we uncrisscross, we get Au plus 1, Cl minus 1, and since Cl does form a -1 anion, our Gold's charge is plus 1.